with all the due respect to, I don't know who was the producer of that movie, Three Idiots. Our definition is still the same definition what the professor follows.
So that means whatever the popular definition of machine was given by Mr. Ranchor Das, Rancho, कि पेन का निप से लेके पैंट का जिप तक सब
No, it's not. Please, it's not. Zip is just a zip. It is not a machine.
देख ना पेन का निप पैंट का जिप है ना
No, वो तो आप लिख रहे हो ना. Pen is not writing. Pen is not writing on its own. You are writing with a pen.
ऑलराइट तो जो मिस्टर चतुर रामालिंगन ने डेफिनेशन दिया था जिसको रिडिकुल किया गया है मूवी में दैट इज द करेक्ट डेफिनेशन
That is the correct definition. In fact, sometimes when people they say that this is the truth of life, this is truth of universe, I generally make a statement that only the second law of thermodynamics, that is the truth of universe.
यू कैन नॉट बी 100% एफिशिएंट कुछ ना कुछ नॉइज में जाएगा कंस्ट्रेंट मींस
That
इट
is
इज
too-
नॉट हेयर
That is too
predictable
technical.
means you know it's going left or right top or bottom
Yeah.
front or back
Yeah. So when you manipulate motion, you
One
have
thing
input
is-
in
थोड़ा
one.
सा, sir. You call this constrained and predictable to be too technical. I find manipulating to be too open, too vague.
Okay.
Precision थोड़ा चाहिए ना
Okay.
मतलब ना माँ ना पिताजी
करने वाला.
कर्मचारी
हाँ, तो बड़ा भैया मान लीजिए जिसने करना है.
ओके सर तो वी आर द ब्रदर्स ऑफ इंजीनियरिंग So hello sir, how are you?
I'm fine, Tay. And how are you?
I'm fine sir. So sir, हम फिर मिल रहे हैं. Last time when we met, we spoke about the universe of IPR, and this entire universe are condensed in half an hour. And I got lot of reviews कि संदीप सर का नंबर चाहिए और जानना है. I think you got disturbed by few. I'm sorry about that, but
No, in fact, people are welcome. If they want to know about IPR or they want to apply for one or the other form of IPR certificate, to help them, it's our duty.
the point is once you're on public, visibility, people might praise you. So
They're welcome to do so.
okay, that's so nice. Sir. I'm guilt free now. But आज तो सर IPR के बारे में बात ही नहीं करेंगे. I have started a playlist in this channel, NBT Conversations, where I speak. In fact, not speak. We discuss about topics relating to disciplines in education, and since our university offers science and engineering disciplines, so my plan is to hit as in like bring experts from each of the disciplines of engineering. So mechanical engineers. I'm also a mechanical engineer. तो आज को और मज़ा आने वाला है सर. So in fact, before you became a mechanical engineer, as an academician in mechanical engineering, आपका तो history भी रहा है, industrial experience भी रहा है, research भी रहा है in some scientific organization. तो आप खुद ही बताइए थोड़ा सा अपने बारे में मेरा audience को.
Okay. First, as a formality, my name is Sandeep Singh. I have taken my B.Tech from NIT Jamshedpur. I graduated in 1995.
उस समय REC बोलते थे ना?
उस टाइम NIT जमशेदपुर को RIT जमशेदपुर बोलते थे, रीजनल इंस्टीट्यूट ऑफ टेक्नोलॉजी.
Okay, all right.
And I completed my master's in field of science of surface coating and tribology from NIT Jamshedpur only. I completed that in the year 2001. That is exactly the same year when I joined NERIST as a faculty here. Then I had a stint of 2 years as a scientist. That was in capacity of scientific officer D at Indira Gandhi Centre for Atomic Research, Kalpakkam.
IGCAR.
Yeah. I used to work there in the tribology department under materials technology division.
Okay, sir.
Basically, but I'll not like to speak about what I used to do there or what was my work.
Is it classified that way? No.
It should be.
That's why. Okay.
I should not speak about it publicly. But I was working there in field of tribology.
Okay.
Then I have taken my PhD from IIT Guwahati in the year 2016. In fact, I was there 2012 to 2015. I submitted my thesis by September 2015 and I defended it by May
May,
2016.
September to May, roughly 8-9 months.
It was not very fast, but at very good pace. And my PhD thesis that pertains to rotor dynamics, particularly in field of active magnetic bearing. And after that, and before that, since 2001, I've been doing teaching at NERIST.
Sir, you graduated in a certain 90s, and
Yeah.
you are done with your M.Tech in 2000s.
Yeah.
So there was a gap.
Yeah, yeah.
So I'm sure you had your industrial experience during that time. बताइए ना.
Yes, after graduating in 95, in fact, I passed out in August 1995. And by the end week of August, I was working with Acropolis Glass Industries Private Limited, which is one of the first 5 ISO 9000
Is it one of
certified
the first
companies
5?
in India. Yeah,
So there were 5 initially.
yeah, yeah.
Okay.
And
Any big name in one of these 5s?
Tata Motors, and uniquely, I was the management representative for ISO 9000 activities and also the manager of quality assurance there.
You were not in the capacity of an engineer.
I was manager of quality assurance.
That is engineering.
Yes,
That would be.
yes, yes. That is engineering management only.
Okay. Because I heard the term management, so I was biased there. Okay.
No, you heard the name manager.
Oh yeah, perhaps.
And after that, I have worked with Drillco, Seiko. They are the people who manufacture cutting tools, carbide tools. And I worked with them for nearly 2 years. The company is headquartered in Pune.
Okay.
And it is one of the very big names. Subsequently, I worked with Gulf Oil India Limited. That is a Hinduja Group company. And
As
as a technical services engineer, because by 96 India was gradually seeing the markets opening up, and engineers, they had offers from multinational companies, and the conventional thought that you need to be working with the government or working for one or the other big Indian conglomerate, slowly it was vanishing. And multinational, that was the buzzword, and obviously the salary offers were really lucrative. So that is how from Acropolis Glass I switched to Seiko, and from Seiko I switched to Gulf Oil India Limited.
and then you pursued academics and now you're here as a professor.
Yeah.
ठीक है सर. अब तो ऑडियंस को एकदम पुख्ता सबूत मिल गया है कि आपकी राइट पर्सन है आज का डिस्कशन के लिए. तो शुरू करते हैं.
In fact, I may not be the ultimate, but I am
ultimate.
one of the persons who can speak a little about mechanical engineering.
मुझे वो लिटिल ही चाहिए. तो मेरा एक दोस्त का बेटा है जो 9 इयर्स का है. मुझे पूछता है, अंकल आप क्या करते हो? मैं बोला मैं मैकेनिकल इंजीनियरिंग करता हूँ. क्या है? मेरा जो जवाब होता है वो टेक्निकल रहता है. आई कैन नॉट कन्विंस हिम कि नॉट कन्विंस, आई कैन नॉट मेक हिम अंडरस्टैंड व्हाट डू आई मीन एक्चुअली.
Okay.
तो आप हेल्प कीजिए प्लीज.
Just pay attention to the finer details. If a building is to be constructed, generally the whole construction will be taken up by one person called a mason.
मिस्ट्री.
Mason. It is not the mason who is responsible for constructing the building. The responsibility lies on someone else. That someone else is the person who basically designs, looks after the area where the building is to be constructed, how high the building should be, how wide it should be, how deep the foundation should be, so on and so forth. This person is the engineer. He is a civil engineer. So if there is something related to building, permanent structures, mason will be the guy who will be implementing the thing. He'll be adding bricks one after the other. But the whole responsibility and the finer details, it will be essentially worked out by the person who's called the civil engineer. On the contrary, if there are things which are not stationary, which are not structures, but they are machines, it may be a mechanic, again a mistri, who may be making it, but the finer details and the finer design, the concept, that will be done by the engineer who's called the mechanical engineer. And if you look at mechanical engineering, the method, the process which makes the needles of this wristwatch tick and move, that particular thing, that is called the engineering, and that is mechanical engineering. Likewise, when the fan, it spins, the three blades, why can we not have a single blade? That decision whether it should have 3 blades, 2 blades, 4 blades, 5 blades, and whether at what angle it should be tilted so that it spreads air all over the room. This decision will be essentially taken by someone who is a mechanical engineer. But making it, it may be a Bijli Mistri who will be making a fan, but the decision essentially will be taken by the mechanical engineer. So anything which is related to machines, that is the field of mechanical engineer.
When you say machine, as you have mentioned, I mean, you drew some comparison with the civil engineering structure. The civil engineering structure per se are static structures, not static per se. I mean, installed in a certain place, but machines are movable, they are mobile.
The whole machine may not be movable. The machine may be laid on a foundation, like a lathe.
Like a lathe, exactly.
But generally, machine will be a device which will take energy in one form, and it will give output, either energy or work, at the other form.
Okay. So, what you have said, my 9-year-old doska beta could connote that कि mysteries for that matter जिसको आप मेसन कह रहे हैं, or mechanic, more precisely mechanics for our mechanical engineers, they do the work and the engineering happens on paper.
Engineering happens by experiment, engineering happens by observation, and engineering happens by continuous improvement. Whereas the mason or the mistri, he works with the same thing all the time and all his life. Whereas the engineer, he learns and improvises every single day. He learns from books, he learns from research of others, he learns from experience, and the biggest teacher, he learns from nature. So if he's doing research himself, he might be doing the mason's job or the
Exactly.
mistri
No,
job
that is
also.
the experimental approach of
Yeah.
okay, learning.
But learning is always open. It can be learned from experience of others.
I mean, he can learn from the behavior of the masons themselves.
Yeah.
Engineering branches, their names themselves are quite self-explanatory. Agriculture engineering. Agriculture means agriculture, right? I don't have to define it. Civil, electronics, communication, what is electrical? Okay, so mechanical word is quite broad in that way. I mean, it doesn't have a specific. I mean, at least for my understanding, it doesn't have a very, domain-specific definition. Like if it's electrical engineering, domain is very clear: electricity.
Right.
Computer science, computers. Computer science and engineering. So mechanical, sir, what does it even mean?
Mechanical, essentially, it means something which is in motion. Okay. Because if you look at the word mechanical in colloquial English, it only means that it is indicating something which is in motion. If something is set in motion, it is mechanical. Like someone who doesn't understand anything but keeps doing something, you say that he's doing it mechanically, right? That doing, it must be associated with the motion. But what appears or what is generally perceived, it may not be the truth. Motion may not be the only criteria. In mechanical engineering, essentially we look at two things. First is energy, and second is motion. Our interest or our basic bread and butter as a mechanical engineer, it comes from taking energy as input, converting it to motion as output, or maybe taking motion as an input and energy as an output. I'll cite both the examples. Like in case of an IC engine, the engine which propels all the automobiles, most of the automobiles, generally we take energy as input in form of inflammable liquids like gasoline or kerosene or diesel. That is the input. And the output is rotation of the wheel. Now, rotation essentially means that it is a motion. So, in case of IC engine, my interest is to take input in form of energy and output in form of motion. But if you look at a turbine, in case of turbine, say a wind turbine, a gush of wind flows past the blades of a wind turbine. The turbine blades, they spin. So we have this motion as the input. And output is generation of electricity. That is energy. So the input is motion, output is energy. Both of these two things, IC engine and a turbine, both are essentially mechanical engineering devices. These are the type of devices that we work with, or these are the devices we work for.
Work with and work for.
Yes.
I can give a rather even simple example for that
Please.
matter. Turbine and pump. In pump, what happens? Through electricity, you attain a motion, rotation of the blades, and because of this mechanical motion, you have a high energy. Water being pushed somewhere, and that is hydraulic energy, water energy.
Right.
Exactly opposite the turbine. You have water flowing down from the reservoir or the dam, whatever that dam is being made from a certain potential height.
Headstock, turbine, tailstock.
That water gives the motion to the wheel, the one wheel, and that generates electricity. What you said is the same principle here as well, right? Energy as at play, conversion of one energy to another energy, electrical energy to hydraulic energy to electrical energy.
Precise.
बीच में खेल हो रहा है.
Precisely.
तो बीच वाला काम हमारा है.
बीच वाला काम वो हमारा है.
इलेक्ट्रिसिटी वाला काम इलेक्ट्रिकल इंजीनियर्स का है.
इलेक्ट्रिसिटी बन जाएगा, उसके बाद उनको दे देंगे, आप उसको डिस्ट्रीब्यूट कर दीजिए, और वो डिस्ट्रीब्यूट करने में बहुत सारा मामला आएगा. स्टार कनेक्शन, डेल्टा कनेक्शन, वोल्टेज स्टेप अप, स्टेप डाउन, डिस्ट्रीब्यूशन से पहले स्टेप अप करना है. दोस इलेक्ट्रिकल इंजीनियर्स विल डू.
ऑलराइट सर, बट
बिजली बना के दे देना हमारा काम है.
बिजली बना के दे देना हमारा काम है कि उनका सिर्फ शाफ्ट को जनरेट रोटेट करना हमारा काम है, उसके बाद आगे तो बिजली वो लोग बनाएंगे ना.
This is where we need to understand very clearly. Like if you are 5 brothers, parents are same, and obviously, however different the 5 brothers may be, there will be one or the other trait which is common between all the 5. So you never can have a sharp division between the fields of engineering. It is overlapping. So the electrical engineer will do something related to mechanical engineering. Mechanical engineer will do a little related to electrical engineering, a little about embedded systems, which means microcontrollers. So he'll do a little of electronics as well. If you look at a tractor, it is nothing but an automobile.
Correct.
But with a different purpose. Rather, it is a repurposed automobile.
There's a straightforward specialization in agriculture engineering, tractor mechanics.
Yeah. So if you are into automobile engineering, you cannot say that tractor, I don't know about it. So these are overlapping things. There is an overlap between mechanical, agriculture, mechanical, electronics, mechanical, electrical, mechanical, computer, everywhere. And practically, as you work deeper and deeper, then you find that these are just names.
What do you mean, sir? Of course, I want to go. Where do you mean? These are just names. I agree. Go ahead. Go further.
Mechanical engineering, electrical engineering, these are just names.
And go further, sir. आगे बढ़िए.
Practically, you are doing one and the single work. Energy in one form, energy in other form.
All right, sir.
And nothing else.
So when I asked you the meaning of definition of mechanical, you said that anything that is in motion.
Generally.
By virtue of its mass, by virtue of its structure, or like.
By virtue of its energy.
Energy.
Yeah.
So there are certain terms which are quite like cousin terms to each other, right? Mechanical. I want to define them. You to define them. Mechanical, mechanics, mechanism, machines. So we are done with mechanical. What is mechanics?
Mechanics is basically a theoretical study of how parts they move.
Motion again.
Yeah. Again, a motion only. Mechanics essentially will have 2 parts. Generally, one part we call it as statics, other part we call it as dynamics. In statics, we perform all the analysis, mathematical analysis, and trying to understand how forces they act on something which is in equilibrium and which is at rest.
Sir, is it like, let's say a certain body is moving, yet we can do static analysis of it? Need not necessarily be at rest, but we can consider it to be at rest at a certain instant.
In fact, I'll need a little of time
Please go
before
ahead,
coming to that.
Okay.
So the first part is statics. So our assumption or our understanding is everything is at rest, so they're at equilibrium. And then we try to know as to how much of force is acting at which particular location. Analysis and applications, they are really important. Like if you look at Bailey Bridge,
What bridge?
Bailey Bridge,
I wouldn't know, sir. What is that?
what you call as Loha Bridge in this area. Steel girders placed one after the other and making a bridge over the river.
Normal, regular bridge. Typical.
Typically what the army constructs, maybe as a matter of 12 hours, as a matter of 18 hours.
They just
like
assemble
that.
them. Yeah.
Yeah.
They're the nut and bolt them.
Yeah, they quickly assemble it, and if they feel like, they'll dismantle and carry it with them.
Yeah. Okay.
Those are the Bailey Bridge. So whether the Bailey Bridge will be sufficient to take load of a tank while crossing the river or not, this type of analysis is essentially static analysis. So this study will be done under statics, which is a part of mechanics. And then there will be case of a projectile fired from India. It needs to land in the adversary country. Here, the object is not at rest. It is continuously moving. It is a projectile. So
In operation, you are saying, right? Not in simulation. I mean, it's
in operation.
okay.
So study of forces and behavior of these type of things essentially would be covered under dynamics, where the thing moves. There will be other examples also, like
There will be a lot of other examples. You tagged that example. I thought
Yeah.
you were coming somewhere else. No, I thought you were going somewhere else, but it was about dynamics. Okay.
yeah. So statics and dynamics, object at rest, object at motion. Perform the analysis of all the forces. That is what you do under mechanics. Mechanics is basically the study. And now I'll come to your question. Like, is it any important to have everything at rest to perform an analysis of forces?
My question was, if something might be in motion,
Yeah.
we can still consider it to be at rest at a certain point in equilibrium, and do the analysis.
Yeah. There is a beautiful concept. Rather, there is a beautiful way, elegant way to do it. Just a few moments back, I said that these are just names. Basically, mechanics, you cannot say that it's pure mechanical engineering. It may be a little of physics as well.
Most of it is physics, I think.
And it may be a little of mathematics as well.
Ah,
Most of it is mathematics.
tool of it is mathematics.
Yeah.
Expression of it is language is mathematics.
Yeah. So,
Phenomenon is physics. Language is mathematics.
yeah. And what you do is engineering, mechanical engineering. Now, if there is something which is moving and still you want to perform an analysis of it as you do in statics. So the first thing is you need to place that under equilibrium. So placing that under equilibrium will require application of a theoretical force which is opposing the motion. So this force will be equivalent, or it will be, in a way equal to mass and acceleration of the object of which you are performing the analysis, but applied in a opposite direction. This is a fictitious force. It's not a real force. But if such a force is applied, then essentially the object will come to rest. The concept was given by a mathematician named D'Alembert. So this force is called D'Alembert's force. And this principle of converting a dynamic system into a static system for the purpose of analysis, this is known as D'Alembert's principle.
It's there already. It's for the public to know. Fantastic.
100% mathematics. Phenomenon is physics, but we use it. This is mechanical engineering.
So mechanics done, mechanical done, mechanism.
Mechanism is basically,
Please bring kinematics there, sir, for my audience. in mechanisms?
An arrangement where you manipulate motion.
You are using the word manipulate.
Yeah. Manipulate, again, since I'm not a man of language, manipulate may have a negative connotation, but here, manipulate essentially means to change the way I want.
Constrained and predictable.
Yeah.
That's how I want to put it.
That is too technical.
Constrained means
That
it is
too,
on haywire.
That is too
Predictable
technical.
means you know it's going left or right, top or bottom,
Yeah.
front or back.
Yeah. So when you manipulate motion, you have
One thing
input
is-
in
थोड़ा
one.
सा, sir. You call this constrained and predictable to be too technical. I find manipulating to be too open, too vague.
Okay.
Precision थोड़ा चाहिए ना.
Okay. So mechanism will be an arrangement with which you give one particular type of motional input to obtain a typical type of motional output. Citing an example, a mini drafter. Two links, a connection, another two links.
Correct.
This will be able to generate parallel lines anywhere along the board.
In any
This-
orientation.
In any orientation. This is a mechanism. The stylus, it follows the original key. The other end, it follows a tool, single point tool. So essentially, as it traces the actual form of the key here, the other side, it essentially cuts precisely the same shape on the blank key.
Profile milling machine, no?
No, this is cutting. It is not milling.
Okay.
And it can be milled also. It can be milled also. If it is hand milling, it can be done like that. So this mechanism, this is called a copier mechanism. Likewise, if there is something, a particular profile, you want to magnify it by 3 times, 4 times. You can have a magnifying arrangement also. Just arrangement of one or the other member. We call those members as links.
Links.
So the links will be so connected that when the stylus traces 1, the output will be 3.
3 times.
So whatever shape it traces here, it draws 3 times larger. These are the mechanisms. Like if you have the luck of having a old-fashioned wristwatch, the wound one, not the, these are battery operated. One with spring loading. If you happen to open it, you'll see lots of things like gears. Those are essentially the mechanism. What it does is, it takes motional input as winding up the spring. And the motional output is movement of the pointer.
The rotary motion is transmitted
Yeah.
to, and what is that called?
On the dial.
Turning
Motion of the...
turning motion itself. It
Yeah.
has a certain pivot to a turning motion.
Yeah.
Okay.
So whatever is inside this, that is what is the mechanism.
So mechanism simply means transfer of motion within the links of the
Yeah.
system, right, sir?
Yeah.
So then I asked you to bring the kinematics here. So what's kinematics? Because you have already defined what is dynamics in mechanics. In mechanics, you say statics and dynamics. So this is
It is a requirement of analysis. Sometimes you're interested more on the forces, and sometimes you're interested more in the motion. So, where you're interested in forces, where you're interested in motion, that will define whether you're handling dynamics, you're handling kinetics, or you're handling kinematics.
so the mechanism essentially would help us in getting the kinematics part of it, because you're actually dealing only with the motion. You don't care how these motions arrived at. You don't worry about the forces involved.
We do.
I mean, sir, if it's
Yeah. For that particular field, yes.
that's what. So it helps the kinematics part of it.
Yeah.
Right, sir. Finally, machines, sir. No, I need definitions. Mechanical, mechanics, mechanism, machines.
With all the due respect to, I don't know who was the producer of that movie, 3 Idiots. Our definition is the same definition what the professor follows. Machine, going by very standard English, is a contrivance.
I didn't get it.
Contrivance, jugaad, plain Hindi, jugaad. Machine, it is a contrivance which takes motion or energy as input at one point and outputs motion or energy in other form at other location. The purpose of having a machine, it may be either to perform an intricate job which generally would not be done by human effort, or it may be to simplify and make life easier for human being. Example, a sewing machine. Sewing, it can be done with needle and thread by hand, but it will take maybe a couple of weeks to complete a single shirt. Where if you make use of sewing machine, similar logic, probably in a day you can complete a dozen. So motion at one end, either with hand or with leg paddle or motorized, and motional output at the other end, that is up and down movement of the needle.
It actually is a transfer of motion only, right? Whatever
Precisely.
motion you say, if it's automobile, it's transfer of motion.
Precisely. Motion or energy.
Motion
Motion or
is
energy.
being created by energy,
Yeah.
and the motion that is the output motion will create some energy.
There may be isolated cases where there is no motion at all, like a transformer, energy as input, energy as output.
Your air conditioner,
100% a machine?
I mean, there's no motion, right? I mean,
Yeah. Motion is inside, but the input and output, they're not motions.
there's energy only, right?
Yeah, they're energy.
So that means whatever the popular definition of machine was given by Mr. Rancho, Mr. Amir Khan, कि पेन का निप से लेके पैंट का जिप तक सब
No, no, it's not. Please, it's not. Zip is just a zip. It is not a machine.
it's a tool.
Might be.
We can call it a tool, right?
Yeah.
A ruler to draw a straight line
No,
is a tool.
that way I can claim that this button is a machine.
So that is stupid, right?
It's not.
It is not. Yeah, that's correct.
The hairpin is a machine. No, it's not.
They are just a convenience tool. I mean, how do I put it, man?
Yeah. This is a mechanism.
Transfer of motion.
Yeah. This cannot be termed as a machine.
Machine needs some respect, right, sir? It's a high degree of complexity. It's simple. We are talking about energy. We are talking about transfer of motions in between so many links within the system.
Yeah.
It deserves some respect. And
Machine, it means it need to do something.
no, even that is doing something. No, pen ka nip, pen ka jib and all.
No. वो तो आप लिख रहे हो ना. Pen is not writing. Pen is not writing on its own.
Okay, here's a better.
You are
now-
writing with a pen.
That's correct. So, all right, it's a better definition now. It has to do something purposefully for which it is designed.
Yeah.
The pen, it may be designed for writing, but I'm the person who is writing. I might use it as a tool. I'm sorry to say,
Right.
to kill somebody. जॉन विक मूवी में तो इसी से मारते हैं, तो उसके लिए डिज़ाइन नहीं किया था ना.
Right.
ऑलराइट, तो जो मिस्टर चतुर रामालिंगन ने डेफिनेशन दिया था, जिसको रिडिकुल किया है मूवी में, दैट वाज द करेक्ट डेफिनेशन.
That is the correct definition.
Because he mentioned about the different links assembled together,
Yeah.
either through pivot point, either through fulcrum, or there were
Yeah,
reciprocating
yeah,
motion,
yeah.
there were linear motions, and some energy conversion. He mentioned everything. That's what exactly academic definition of machine is, right?
No, it's not academic. That is the real definition. That is the definition. That is what the machine is.
सर, ठीक है सर. तब तो मैकेनिकल इंजीनियरिंग क्या है, एक रफ आइडिया आई थिंक एटलीस्ट मेरे ऑडियंस को अभी तक मिल चुका है.
I hope.
हाँ, इसका अंदर पे इन द डोमेन, नॉट डोमेन, इन द engineering discipline of mechanical engineering, what are the subjects which are classified under certain specializations?
Classical mechanical engineering essentially would have two parts. One will be associated mostly with design. Second will be associated with manufacturing.
Design is evident as you have एकदम शुरुआत में आपने जो बोला था, mystery, mechanic versus engineers.
Yeah.
Engineers were designing it. Mystery and mechanics, they were not designing anything. They were executing the design,
Making it.
making it basically.
Yeah. So one part was design, other part was manufacturing. But gradually, newer fields with better understanding of things around ourselves, they evolved. So thermodynamics and thermal engineering, it became a very prominent field. Then gradually the concept of heavier than air floating, that also came into existence. So human being, it shifted from flying in a bucket fitted on a hot air balloon to something called aeroplane. That gave birth to a new field of aerodynamics, followed by hydrodynamics, followed by studies in all this field. So we have a new field of fluid mechanics, and fluid, it doesn't mean only the liquids, it means gases as
Gases,
well.
yeah.
So aerodynamics, fluid dynamics, everything is there. And very recently, we also do have a new field of mechatronics. And all these fields, they have further ramifications, further branches, further specializations.
Sir, let's speak one by one.
Please.
You said design aspect of it.
Design.
Well understood, because we started our discussion with that.
Yeah.
Next, you said manufacture.
Manufacturing.
Right? Like whatever you design finally has to be
Yeah.
manufactured. Then you say the environment on which the design is being made, or it will be made to operate. The environment, air, water, whatever, the nature. There's thermofluid engineering, right?
Right.
Then you have said mechatronics with advancement of digital technologies. You are not collaborating. You are working together
Yeah.
with that system. So there is industrial engineering as well, because industries are also being studied under mechanical engineering umbrella. Management would come under it, right, sir? So let us speak one by one, starting with design engineering. What are the subjects?
Academically, under design, the very first thing that we study or what we teach, that is engineering mechanics.
Mechanics is understood. You have defined it.
Now I'm talking of engineering mechanics.
Now tell me difference
So-
between mechanics and engineering mechanics.
Engineering mechanics is a subset of the mechanics, which is a bigger field.
So again, there's a subject called technical mechanics as well.
It's same.
Same. Engineering and technical, they are same.
Same. In engineering or technical mechanics, we essentially look at applications and we perform the analysis of that. Whereas mechanics itself is vast,
It's
really
science.
vast. Yeah.
It's science,
Yeah,
not
it's
necessarily
science.
application.
And it may be analyzing anything.
It need not be application based analysis.
Yeah.
But engineering mechanics is application based analysis.
Application based. We'll start from there. Then we'll take theory of machines, which further will be divided under kinematics of machines and dynamics of machines.
Which you have already mentioned. Kinematics is motion and dynamics is process.
Yeah. And we'll have beautiful names also. Like sometimes we'll call that as DOM, theory of machine. We'll call it as DOM, dynamics of machine,
machineries.
COM,
Kinematics.
kinematics of machine. So that beauty also will be there. After that, we'll take design of machine elements or machine design.
वो क्या होता है?
That is essentially trying to design. And when I say design, essentially the idea will be selecting a suitable material for that particular component,
Correct. That's one.
dimensions,
Length, breadth, height, or whatever.
Yeah.
Curvature.
then the most beautiful profile. Not beautiful by visualization, optimum shape. So example will be like designing a machine component, design of a machine component, like designing a lever.
Lever. Okay.
If you look at the brake lever
Brake.
or brake lever on a motorcycle
Oh, okay.
or clutch lever
All right.
on a motorcycle or gear shift lever, you'll find that it is a simple component like this with one end extended here, another end extended here. Because the gear shift levers, they essentially work on both the directions. So identifying as to how big it should be, how thick it should be, what materials should be used, this is essentially what is taught under design of machine
Elements.
components or design of machine elements. These are machine elements
Which is different from machine design.
slightly. These are the components. This is the component level design.
Okay, as you said, as I have said, machines need some respect. तो वो थोड़ा बड़ा है.
Okay. Yeah. And then if you look at a ball bearing,
हाँ.
so in ball bearing you have an inner race, you have balls, then you have retainer, and you have an outer race. So essentially there are 1, 2, 3, 4, 5 components. And then to keep it running, you'll put some grease also. The grease will flow out. So you'll give a shroud So fifth, sixth, seventh, eighth, those machine elements will go on adding one after the other. So you can call this as a machine. So a ball bearing may be a machine, but the shroud of it, it will be a machine element. The motorcycle is a machine. Clutch, gear shift lever,
Yeah,
these are the
elements.
machine components
Machine
or the machine elements.
Correct. All right. So basically, you have to first undergo design of machine elements to have merit to study machine
Before
design.
that, you must study
Mechanics.
the theory of machines
Theory of machines and mechanics.
and mechanics.
Because these are the basic science
Yeah.
through which. Okay. All right. Then you have solid mechanics as well.
In fact, when you take a decision on the size of any of the machine components, so that size will depend on how strong a particular material is. Now, I'd like to make an example. Can I use this?
Go ahead, sir.
Say, I want to place it here and I wish to support a load. It will not. But on the contrary, if I apply a little of engineering, not much, a little.
So what you're doing right now is engineering.
Yeah. This is strength of materials. A few more.
Right, sir.
And this strength of material, it is not only a paper to be studied by mechanical engineers.
Civil engineers have to study.
It is taught and studied by civil engineers
Agriculture.
and also agricultural engineers.
All right, sir. Design बहुत मजा आ गया. अभी मैन्युफैक्चरिंग इंजीनियरिंग में क्या क्या होता है?
Anything that you make a plenty.
What?
If you're making one, the workman can do it. But if you're making it in number, that is plenty of it,
Mass production.
yeah, mass production, then essentially you need to have a particular method how will you produce it.
We have to
And-
develop a system.
Yeah. And one of the most beautiful part of mechanical engineering, it comes in manufacturing sciences by way of transferring quality from hands of the workman to the machine.
Sir, repeat again.
Manufacturing technology,
Ah.
it transfers quality of a product from the hands of a workman to the machine. And since the machine doesn't have a brain, essentially every component has the same quality.
All right.
How does it feel?
It feels nice. I mean,
I'll give you an example. My wife, she rolls chapati for me every day, but none of the two chapatis will be the same.
and neither the chapati for you and your son will be same.
None of the two chapatis in my plate will be same.
Okay.
Forget what will be in my plate and my son's plate and my wife's plate. And for that matter, it goes true for everyone. In the sweet shop, two sweet, whatever name it may be, gulab jamuns, they won't be exactly identical if it is handmade. But every pack of Maggi, the noodle will appear exactly the same because it is made by machine. So manufacturing or making of something, your whole purpose is to shift the quality from the hands of the workman to the machine. And since the machine doesn't have a brain, it doesn't have sentiments, every single piece manufactured will be exactly a replica of the other
Standard.
one. And this, paves way for mass production. And when you're trying to produce in numbers, essentially the workman-based manufacturing will not do. So when you plan to make things in good number, huge number, that is exactly what is dealt or what is covered under manufacturing technology.
Subjects बोल दीजिए कुछ कुछ.
Start करेंगे from casting,
Casting.
then it may be wrought, pitting, और ये
वो-
hammer से
हाँ,
wrought करेंगे उसको,
उसका metal working में आता है because working on the metal.
हाँ, metal working करेंगे. Then if better finish, better shapes are to be given, it may be cut with a single point cutting tool.
Machining कहते हैं उसको. Just like
That
sharpening,
is
sharpening your pencil.
metal machining. Then there will be associated processes like hardening and all. So there will be surface treatment, carburizing, nickel hardening, all these things. And also there will be new generation manufacturing methods like additive manufacturing. Like if you look at metal cutting, to obtain a particular shape, the unwanted material is removed.
It's material removal, negation of material.
Yeah. On the contrary, in additive manufacturing, it is like if you are constructing a building, you do not have a pre-made building from which you are removing the things
It's
so
not
that
like-
a space is created.
Basically, you are not sculpting.
Yeah. But what you do is you already have the space available and you are building brick by brick the walls. So similarly, if you're able to make components piece by piece, part by part, gradually developing, we call that as additive manufacturing.
So this comes under the manufacturing.
Yeah.
Where
This is
would-
a new generation.
Where would you put this material science? In design part or this part?
In fact, again, material science is one which is studied by everyone, all the engineers, including electronics, telecommunication, electrical,
Physics as well.
physics, yeah, chemistry as well. So material science is more of a support system for mechanical engineering. It is not a core part of.
But if we have to put it, where should we put it? Manufacturing part. If it has to choose a home, where should it go?
It is.
Standalone.
It's not that. It's not standalone. It's like. How do
कोई
I
पार्टी
put it?
में घुसना है ना सर, बीजेपी जाएगा कि कांग्रेस जाएगा?
नहीं. It is like the election commission.
अच्छा, उसका बिना बीजेपी भी नहीं चलेगा.
Everybody will report to election commission.
अच्छा.
So material science will be the one which the designer will require, the manufacturer will require,
Even the third category,
Yeah.
you say, thermofluid.
thermofluid they also will require it. If you look at AC ducts, generally it will be copper. Why not have plastic? So the answer will essentially come from material science only.
So election
It is
commission.
indispensable.
Indispensable. It is part of
Yeah.
it. It is like the framework based on which everything will happen. Otherwise, materials ही नहीं है तो किस चीज में काम करेंगे?
It's like water. It doesn't test anything, but without that you cannot do.
All right, sir. So we are done with manufacturing science as well. Now, next, thermofluid engineering. Just subjects का नाम mention कर दो, because this is an awareness conversation. So
Thermodynamics,
thermo means
temperature,
dynamics
or heat,
means
motion.
वही बोल दिया जैसे हमने पहले बोला.
So either you can take it as motion of the heat or motion with heat. Either. But basically, engineering thermodynamics or thermodynamics per se, it gives you beautiful concepts like you cannot create energy. You can only, change its form. So that will be the first law of thermodynamics. Then essentially, when you're looking for efficient and more efficient machines, as an engineer, you may target having an idea that I can make something which will utilize all the energy which is at my disposition and convert it to the useful purpose, 100%. That means a machine with 100% efficiency. Whether you can really do it, what are the bottlenecks, why you cannot do, or if doable, how it is doable. These things will be covered under second law of thermodynamics. It will gradually introduce the concept of entropy. Like the first law of thermodynamics, it introduces the concept of enthalpy. Enthalpy, that is the energy which is visible, the energy which is not visible, but you know that it is there. So sum of both, that is the enthalpy. And then, beautifully and very interesting, you have the first law of thermodynamics, second law of thermodynamics, speaks of heat and temperature. And you exactly do not know how to measure the temperature. So you define a particular scheme. You say that if A is in thermal equilibrium with B, A is also in thermal equilibrium with C, it would imply that B and C are also in thermal equilibrium.
Because there is no direct measurement. If I have to measure this length, centimeters straightforward, इसके लिए मुझे किसी और के पास जाना नहीं है.
So this will give you an idea how to create a thermometer. Now, before you are able to use first law of thermodynamics and second law of thermodynamics, you need to have a thermometer. But thermometer essentially would be created only when you follow this particular logic.
A equal to
Equilibrium of
B,
A, B,
B
A,
equals to
C
A.
means equilibrium of B and C as well.
Ah.
So this particular law is called zeroth law of thermodynamics because you already named first and second. So there should be something preceding this. So it is called the zeroth law of thermodynamics. So you have zeroth, first and second law of thermodynamics. And once you know that how efficient you can convert energy, practically the thermal energy from one form to the other, you will essentially try to learn or study about boilers, heat exchangers, fins. So heat transfer, that also will be one of the topics covered in this. And then energy generation methods,
Energy conversion.
energy
In
conversion.
fact, sir, only this part of mechanical engineering touches upon the concept of philosophical universe. Energy can neither be created nor destroyed. Let us not. I'm not going there. Just saying it.
Yes, yes.
Like,
yes.
and you can never be 100% efficient.
In fact, sometimes, sometimes when people they say that this is the truth of life, this is truth of universe, I generally make a statement
बोलिए.
that only the second law of thermodynamics, that is the truth of universe.
You cannot be 100% efficient. कुछ ना कुछ नॉइज में जाएगा ही. खाना खाते हैं तो हागेगा ही.
होगा ही, कुछ तो निकलेगा. रादर आप उसको थोड़ा दूसरे फॉर्म में लेते तो ज़्यादा अच्छा था.
हाँ.
गोबर से आप कितना भी जलाएंगे, it never will give you flames.
Okay.
If you make cow dung cakes and burn it, it will never give you flames because at least half the energy of grass that has been taken by the animal. And
Correct.
what has come out as cow dung only carries half of what it used to have earlier. So if you burn dry grass, you'll have big flames. But if you burn cow dung cakes, you never can have flames. But you never will have a cow dung which will not burn.
It will, but
It will. What it means is cow cannot digest 100% of the grass. So some energy will come out. And that energy essentially will be many a times lower than the energy that the grass itself has. So the dry grass, it will burn with big flame. This never will give you flame.
So, all right, sir. So that was about the thermal part of thermofluid engineering. Fluid engineering के बारे में एक दो लाइन, एक दो subjects.
वो उसको थोड़ा ऐसा समझते हैं. The very first thing is water, which is at an elevation, will carry potential energy. So when it flows down, you can convert that potential energy of water into a rotational form. That rotational form later on can be used to convert that motion to electrical energy.
That we have mentioned previously for some time.
So while studying this, it is very important to see whether that flow of water, it is laminar or it is turbulent. If it is turbulent, then maybe the conversion factor, it may be poor. If it is laminar, the conversion ratio, it may be fair. Similarly, if a submarine is to float inside seawater and to move near the seabed, essentially it will have to navigate itself through water, which is salty water, and it has greater density than the water that we drink. Then the aeroplane which has to fly, essentially it has to float itself in air, wherein the aeroplane itself is many a times heavier in density.
Many times?
Heavier.
Always, no?
Many a times.
What do you mean, sir?
Multiple times.
Okay.
So for this type of things, it is very important to study the practical behavior of fluids. So this particular study that will be generally taken up under hydraulics. Also the behavior, how the fluids will behave under different conditions and how it can be exploited for the purpose of mechanical engineering, like Pascal's law, which will be the basis for design of a hydraulic lift or a hydraulic ram. Then method of suction, method of compression, all these things, they will be studied under hydraulics,
ये भी
hydraulic
mechanics ही है.
machines.
लेकिन फ्लूइड का मैकेनिक्स है,
फ्लूइड का मैकेनिक्स है और बड़ा टिपिकल एप्लीकेशन है।
सब्जेक्ट का नाम ही फ्लूइड मैकेनिक्स है।
हाँ, उसके बाद फ्लूइड मशीनरी भी होगा।
मशीन आ जाएगा उसमें।
देन कोई भी काम करने से पहले विल एसेंशियली ट्राई टू do a computation and check whether my idea will really fit or not. Now, experiments on things like an aeroplane, it's very expensive.
Or for that matter, even let's say
Spacecraft?
spacecrafts.
Yeah, it's very, very expensive. So, for generally this type of applications, we do not go for experimentation in the first go itself, but we try to simulate the behavior. So, computational fluid dynamics, that is one of the big areas in which mechanical engineers they work. Later on, behavior of some of the fluids which are very quick at transforming their phase from liquid to gas, and their combination with thermodynamics and heat transfer, that gives birth to the concept of refrigeration. So there will be a little of fluid mechanics there and a great deal of thermodynamics. That particular field that will be termed as refrigeration and air conditioning. Finally, there remains industrial engineering.
Mechatronics as well.
Yeah, about industrial engineering, there are multiple decisions to be taken, particularly by the mechanical engineer, because may it be any factory, any industry, generally the manager will be the one who will be a mechanical engineer, because it is believed that they are the people who are into manufacturing. Even inside a electronics component manufacturing unit, the plant head essentially or the shop floor manager will be essentially a mechanical engineer, because he is expected to be the one who will be expert of manufacturing, whatever it may be.
That means China में manufacturing engineers, I mean mechanical engineers को मस्त नौकरी मिल रहा होगा.
काफ़ी है, हमको आपको भी मिलेगा. I mean it.
हमारा तो स्टेबल वीज़ा लगता है, इसमें नहीं जाएंगे वापस.
वो हम लोग तो अरुणाचल में बैठे हैं, ऐसे वो स्टेपल वीसा दे के क्या वो ऐसे पैदल ही चले जाएंगे. दिल से वेलकम.
So I've actually touched the Chinese land in Bumla Pass. I did that. Anyways, let's just continue, sir.
I did that in Nathula.
Okay, sir.
Inside an industry, just look at a situation. Say, in one particular shift, exactly 500 number of components they have been manufactured. And you want to ascertain the quality of all that has been manufactured. And say, the testing is destructive. If you test one, can you be 100% sure that remaining 499 components, they have the same property?
Not at all. Just like testing matchbox.
Yeah.
I mean matchstick.
Yeah.
If it lights,
Yeah.
then you have to test all.
Yeah. So if you have lighted all, what you'll use then?
That's all.
So if you have tested all the 500, what you'll sell in the market? So a practical application is to be developed, which will tell, if you find the first one to be defective, take this action. If you find the first one okay, test a few more, but don't test more than this before you take a decision, either to reject or to accept the whole batch. This type of decision making essentially falls under the field of industrial engineering. And the decision making and making of that plan, inspection or sampling plan, that is job of the mechanical engineer.
So the management aspect does come under industrial engineering.
100%. So there will be other things like operations research. Operations research that essentially would mean if multiple steps are involved in manufacturing a particular component, how and at what particular situation, which particular process is to be preferred or is to be given priority. So the whole purpose of operations research will be to optimize profit of the company.
Correct.
So industrial engineering essentially would be related to a little of legality, all the laws of the land related to industrial procedure that needs to be understood and taught, learned, simultaneously taking decisions on quality, on inspection methods.
So there will be a lot of statistics here.
It is.
I mean, compared to
There
the
is.
other side of
There is. Lots of probability and statistics involved here.
standardization will come here as
Yeah.
well.
Then when you manufacture, uh, it must fit in the mating component where it will be utilized. So standardization, then following the codes of the country where you intend your product to be sold later on. All these things will be covered under industrial engineering, and operations research essentially will be a big part of it.
So finally, mechatronics, sir.
Yeah, mechatronics, that is the great thing. Practically, when you look at consumer electronic products, there is nothing which is 100% electronic.
Like your mobile phone.
It is not. I'll speak of that. When you look at the so-called mechanical product, it is not 100% mechanical. Like if you look at washing machine, it is a machine by name itself. Its activity also is sufficiently of a machine. It performs 1 2 1 2 washing, then it spins.
Motion by virtue of
Yeah.
this.
So lots of motion is visible. But do you think that such a motion, like reversal of direction of movement of the washer, can that be done without a microcontroller? No, it cannot be. So the mechanical components essentially will need one or the other electronic component to make the whole motion possible. Otherwise, it could be done otherwise also by making use of with both quick return mechanism and all others.
But that will be
But
very slow.
it will be enormous, big, bulky.
It will be slow as well.
Yeah, and it will be slow. It will consume lots of energy. It will be inefficient. So, if you want to have things optimized, the mechanical component must come in conjunction with the electronics. And for the mobile handset, it has a if you put it on silent mode, how do you get an idea that you have a call waiting?
It vibrates.
So that is a mechanical component.
Motion.
Yeah. So that way, every electronic will have a little of mechanical associated. If you talk of sensors, a particular device which will sense proximity, like this mobile, like when you place it close to your face, the screen, it will switch off. So there is a proximity sensor.
And what's the utility?
So moment it senses that you are placing it close to your face, obviously you are not looking at the screen then. So why the screen should be
Or energy
on?
conservation.
Yeah. So it will switch off. And just to test, if you bring it close to a wall, still it will switch off. Because it is just sensing how far is the obstruction. That is a proximity sensor. Likewise, there is a gyroscope also. As you tilt the handset, the screen, it rotates.
Auto-rotate.
So that auto rotation essentially is assisted by gyroscope. Now, rotation is mechanical thing. You cover that under mechanics.
Mechanism.
Mechanics.
Mechanics.
You're giving a rotation. You're bringing it close to a particular obstacle. This is mechanics. And how you generate the signal? You generate the signal electronically. So these type of sensors, they essentially are combination of a mechanical component with an electronic component. Study of this type of mechanisms, machines, devices, that is covered under mechatronics.
So, sir, we have covered almost, of course, not 100%, but majority of the domains of mechanical engineering.
Practically tip of the iceberg.
Yeah, actually. Because if we go ahead, we have AI, ML, everything. But we are not going there, all right? ठीक है, वो अभी उसका ख़त्म कर देते हैं. जिस मेरा ऑडियंस को जानना था मैकेनिकल इंजीनियरिंग में क्या क्या पढ़ना होता है, आपने बता दिया. एंड नाउ दे विल बी अवेयर कि जब मैं सब्जेक्ट लूँगा तो क्या क्या आएगा उनके पास. सर, मैंने previously I've spoken with a professor from agriculture engineering and one from civil engineering as well. The professor from agriculture engineering, Professor Arnab Bandyopadhyay, उसने कहा था कि popularly agriculture engineering is called the mother of all engineering or father, either of them, and father of all engineering, sorry. And Dr. Devendra Pal, an associate professor from the Department of Civil Engineering, he again said rhetorically that civil engineering is called as the mother of all engineering. And I was on this side of the table. I'm a mechanical engineer. So if somebody calls me tomorrow on that side of the table, and if they ask me कि what is your familial position being a mechanical engineer? I don't know what would I say. तो आप कुछ बोलिए इस बारे में.
I would like to give a very brief history
Okay.
how these names they have originated.
Okay, sir.
The word engineering, essentially, like if you look at the dictionary meaning of it, it will tell you that to engineer as a verb, it means to plan.
To plan.
Yeah. So, like you might have come across, he plotted the conspiracy, he engineered the conspiracy.
He engineered the, let's say, murder.
Yeah.
Correct.
So, essentially, making a plan and execution, that is what is called engineering.
Okay.
So, there are two type of activities under engineering. One may be related to military, where a planning and execution is required on a continuous basis.
Okay.
So, there is military engineering. And if it is not related to military, it is civil engineering. That is engineering meant for the civic society.
Civil society.
Yeah.
Civilians.
Yeah, civilians. So that way, mechanical, electrical, electronics, everything is under civil engineering only, because we are not doing it for military.
1 second, sir. Why can we not do it for military? All the tanks that are made, who made that? Who made those tanks? We know mechanical engineers, right? How are we not doing for military people?
See, the engineering that we do not do it for military. Our planning is not for military. Our planning is for our product. Later on, the military uses it.
Okay. Okay.
That way, like whatever agriculture engineers do, the final result is a very good harvest. Military also eats it.
Oh, yeah.
So it is used by them also.
Correct, correct.
But military, other than Pakistan military, they are not into agriculture.
Okay.
Again, no bad feelings for Pakistanis, but other than them, there is no military in the world which is into agriculture engineering.
Okay, sir.
But they use the agricultural products. But later on, what happened? After invention of the first steam engine, and when it was attempted to be patented, somehow the civil engineers of those days, they were not very convinced that this product, the steam engine, it falls under the category of civil engineering in any way. And that is where the particular term mechanical engineering was coined.
Oh my God, really?
Yeah. Before that, only two engineerings: military engineering and civil engineering.
Okay, okay.
If it is not related to military, it is civil engineering.
So it has a historical connotation.
Yeah.
Oh, okay.
Then gradually, generation and distribution of electricity, it was taken up as an independent activity, independent from mechanical and civil. So the name electrical engineering. Later on, because engineering which is solely dedicated to agricultural practices, that was taken up as a field of study, and the name agriculture engineering. So these names practically they're not ancient names.
Okay.
They're not ancient names. These are not even 100 years old.
Okay.
Very new phenomenon.
Okay.
Civil engineering and appearance of mechanical engineering as a name, maybe 150 years old.
Oh, after Industrial Revolution.
Yeah. After an attempt to patent the steam engine.
Okay.
And likewise for electrical engineering. Electronics, telecommunication, very recent. Computer science and engineering, very recent. Agriculture engineering, relatively old, but quite recent. Relatively old, but quite recent.
Okay.
And to be very frank, our position in field of engineering is mostly like a serviceman, कर्मचारी.
मतलब ना माँ ना पिताजी,
करने वाला.
कर्मचारी.
हाँ, तो बड़ा भैया मान लीजिए जिसने करना है.
Okay, sir. तो we are the brothers of engineering.
या ब्रदर बोलिए, बिग ब्रदर बोलिए.
ठीक है सर.
Proper word is कर्मचारी. And something on very serious side. One of my uncles, he used to work with Tata Steel. And he was awarded with the Viskarma Award also by President of India. He once told me that mechanical engineers are slightly on the higher side of an industrial worker because he's quite educated. So mechanical engineer, he should take pride in being the karmachari.
100%. Um,
Feeling okay in the family?
yeah, I want to be part of. I wanted to be part of the family. Basically, I wanted an answer. If tomorrow somebody calls me and asks me this question, what would you be as the familial position? Now I have an answer. I'm the brother of the family. The responsible brother of the family who keeps the family rolling. All right. So, we as mechanical engineers, the kind of mechanisms, machines, or for that matter, any system that we develop or design, we take a lot of inspiration from nature, right, sir? तो भाई एक मैंने लाइन बोला और आपका एक कमेंट चाहिए इसमें लाइक नेचर से हमने बहुत मिमिक करके हम सिस्टम डेवलप करते हैं सर इस पे आपको कुछ कहना है
इनफैक्ट जितने भी मैकेनिज्म हैं और कोई नया भी अगर हम डिज़ाइन करते हैं या उसकी कल्पना करते हैं it will essentially come from nature. As an example, when you look at the arms, it is thin here at the wrist and it is thick here.
Correct.
This is precisely how we design a lever.
Lever, okay.
Yeah. When you hold a weight here, this is the position where you have the minimum of bending moment. This is where you have the maximum of bending moment. So this is where there will be the biggest of stress. So this place is having bigger mass so that the load is distributed and the stress is almost uniform all over. Right?
Right.
So if you design a lever, your design will be exactly like this.
Okay.
Location which is close to the pivot will have a bigger cross section compared to the one where the load is applied.
Just like the gear lever that we see in the car.
And this exact shape you'll see inside a crank. Crank and connecting rod, if you look at.
Yes.
Essentially, the upper side will be smaller in cross section.
Yes.
The other side will be bigger in cross section.
Yes.
In fact, not few. Almost every design essentially takes inspiration from nature.
I mean, these are all anthropomorphic. That's the term, right?
Yeah.
Like human anatomy is being mimicked in the machines.
Yeah.
Because they are just extension of what we want to do.
It's like for the people who are religious, this is God's design.
Us.
Yes.
Okay.
Not only us, the whole nature.
Yeah, the whole nature.
The way a tree stands, the way four-footed animal, they move and they walk. If you design a four-wheeler on the line of a four-footed animal, that shape will be the most optimized shape.
Okay.
And if you happen to check it, you'll find that yes, it's like that only.
Okay, the inspiration came from four-footed animal. Four-footed animal, okay.
From nature.
Wow. So, all right, so nature itself is not mysterious. We have a lesser of faculty to comprehend nature. By faculty, I mean our brain, eyes, and
right.
So if nature reveals itself, we call it magic. But it's not magic. It was always there. So when I use the term magic, can you, sir, mechanism, as you have said, or mechanics for that matter, there could be some mechanics or mechanism that you would consider it's magical. I mean, at least for people, laypersons, oh my God, ये क्या हो गया types. ऐसा कुछ है तो आप बताइए.
In fact, I don't find anything magical.
Okay.
Because people who lived before us, they have sufficiently explained.
What?
Whatever happens.
Not all of it, of course.
Quite a few that amazes us. It has been well explained. But yes, there will be certain things, when you look at it for the first time, it may be a bit intriguing. It will raise your interest. Look at this arrangement. There is a cellulose scale. And I have hung a hammer with a string. And you will see that the scale is supported only at one hand. Still, it doesn't fall. If you look at this for the first time, maybe it will appear that it's not real and it's supported somewhere else. But no, it is supported only at this particular point. This is basically the concept of a counterweight in mechanical engineering. Counterweight. If you make analysis of this particular scale as a beam, it will have 3 points where the reactions will appear when you draw the free body diagram. One reaction will appear here, another reaction will appear here, third reaction will appear here. The reaction here essentially is opposite to the weight of the hammer at this particular location. This weight is acting downwards, so it is pushing it upwards. And a part of the weight of the hammer, it is getting supported at this particular point. So here it is getting pulled downwards. Based on as to what is the magnitude of the force acting upwards here and magnitude of the force which is acting downwards here, the reaction force at this particular point, it is very important. It won't be acting upwards, it will be acting downwards. So since the force acting here is acting downwards, so the scale is held tightly against the table. But on the contrary, had the reaction force while drawing the free body diagram been acting upwards, essentially the upward force will make this scale topple and the whole thing would have gone down. This demonstration essentially, when I look at this as a, like when I saw this, yeah, it really appears magical.
For kids.
Yeah, for kids. But when I do analysis of forces acting on this, it really tells me and it convinces me what I teach in engineering mechanics.
Sir, now can you disassemble on camera? Just to prove it that
There, there is nothing like on camera.
All right, sir. Wow, sir. So that was quite magical, at least for.
Thank you.
I mean, yeah, I teach mechanical engineering papers, but this kind of example I've never seen on any book.
In fact, it had only three things: the scale from my sitting chamber, the hammer also from my sitting chamber, and the thread, which generally I wear in my neck.
All right, sir. That was quite comprehensive discussion on mechanical engineering. I think it was very complete in all its layers, and we have hit 1 hour mark. So,
Okay.
सर आप यंगर जनरेशन्स को एनकरेज कीजिए मैकेनिकल इंजीनियरिंग क्यों लेना है और मेरा ऐसा ऑल जनरेशन को भी बोलिए कि मैकेनिकल इंजीनियरिंग को सीरियसली क्यों लेना है कैमरा में देख के बोलिए सर
This is for all the aspiring students, those who would like to come to NERIST after they complete their class 10 or class 12.
Why NERIST anywhere mechanical engineering? Keep it open.
In fact, I market NERIST only.
Okay.
But I do not market mechanical engineering only, I market all the engineering. So if you happen to come to NERIST for a graduate course, undergraduate course rather, you can think of opting for mechanical engineering. Reasons being, mechanical engineering essentially will give you great deal of knowledge which you will require in your life. Things which are called common sense but which are not so common. Things which are told that they are very useful but are never given. Those will be given in mechanical engineering. All the subjects that I outlined during the discussion, essentially you'll find them very interesting. Apart from being interesting, they will be also very challenging chapters, very challenging subjects to study and master. But once you start mastering them, your self-confidence will not jump, it will skyrocket. When you look at anything in and around yourself, a mixer grinder, a washing machine, a small device, a hammer, a tool, essentially mechanical engineering. And if you look at bigger things, the best of the car in the market, Concorde, aeroplane finally grounded and Boeing taking place of that. These are essentially mechanical engineering. BrahMos missile, its trajectory, its motion, drones, essentially mechanical engineering. But do remember, mechanical engineering, and for that matter, engineering, any engineering, is not a stand-alone field in itself. It essentially would take help of other branches of engineering, other fields of knowledge. So, under a course in mechanical engineering at NERIST, and for that matter at any other institution, over and above the core mechanical engineering, you will be given an introduction or at least a one semester course on electronics, a few semester courses on computer science, and a few semester course also in field of civil engineering, so that whatsoever is required for your profession, you know it. As for your future after you complete your studies in mechanical engineering, biggest thing that mechanical engineers can do is they can run their own business. That is the first thing that everybody should target. And second one, you will have plenty of opportunity in private sector, particularly in factories, and also the same number of appointment offers that the electrical or the civil engineer has with the government, the same number of vacancies that remains for the mechanical engineer also. If you're targeting government job, mechanical engineering should be the first priority, because in India, government runs lots of industries like Balco, Hindalco, Steel Authority of India Limited, essentially or into manufacturing. So mechanical engineer has a great scope there. Among private sector also you have a great scope. And if you are willing to do a business, not as a serviceman but as a boss, mechanical engineer is ultimate as one doing it. And there are examples also for your motivation. Anand Mahindra is himself a mechanical engineer. Mahindra and Mahindra, the boss there. Bajaj, the younger one, essentially he is also a mechanical engineer. These are two examples, and there are many more. And
हमारे लिए कुछ sir.
for they, please take pride in being the serviceman.
I'm proud of it, sir. Thank you, sir. Thank you, sir.